So in this lesson, I want to go over some of the main helpers provided by Phoenix that will help you control the simulation or create some cool effects. So we've already covered the liquid source, which we use to add emitters and emit liquid out of various objects. Now again, under helpers, Phoenix FD will see all of the helpers here. So the other one I want to go over, let's do them all. So let's do plane force. The arrow here indicates the direction in which the liquid will be pushed. So I'm actually going to rotate this 90 degrees. And let's just check my grid settings. So the resolution is really high right now. So let's make it something manageable, just so it's fast. And under dynamics, maybe let's make the steps per frame 4. Just because I want to quickly show you how these helpers are working. So as you can see, the liquid is being pushed to the left. Now you can control how strong this plane force is with this strength. So we can maybe make that 350. And you can see that now we're getting a much stronger effect. So this drag here goes from 0 to 1. And it basically controls how much of the velocity will be negated over a period of 1 second. So if I set this to 0.5, I'm basically telling Phoenix that I want to slow this liquid down by half over a period of 1 second. And 1 second in our case is 30 frames. So let's just see what that will do. Basically what we should see is that the liquid should slowly slow down. Now, it's difficult to see here because it's still being affected by gravity, so we're not really sure if it's working or not. But one way to make sure that it's working is if you set it to 1, it should just completely stop the liquid from moving. And as you can see, that's exactly what's happening. So basically 100% of the velocity is being stopped almost immediately, and the liquid is just being accumulated here. So this is a useful parameter for something like splashes, where maybe you want to slow down the splash as it's sort of splashing over time, to stop those edge droplets from flying all over the place and similar effects like that. Now max distance would be the maximum distance within which the force is being applied. So let's say that if I made this 50 centimeters, but this stream of water continues past 50 centimeters, it will stop being affected after it's beyond 50 centimeters away from this icon here. And one important thing is this apply force behind icon. So right now our liquid is in front of the icon because the arrow is pointing this way. Now if I move the icon over here and hit start, you can see that it's not being affected anymore because in Phoenix's eyes, the liquid simulation is now behind the icon. So if I still want it to be affected wherever it is, you have to click this apply force behind icon. You can see that it's being affected again. So this is just something to know about. So we did plane force. Now we can do follow path, which is a fun one. We're doing an entire project in this course based on follow path, but I just want to give you a quick introduction to all of them. So for follow path to work, we need some kind of a path. So you would go under shapes and you could create a helix and just drag one out like this. And maybe we can change the color to something we can see. So a bright orange would do. Now the thing to know here is that it matters which point is the beginning of the path and which one is the end, because by default, as you go under the path follow and under spline, you select your spline, the liquid will be attracted to the starting point of the spline, which right now is the bottom point down here, not this point here. So I actually need to flip this 180 so that the beginning of the spline is where our emitter is, right there. And let's go into the path follow. Let's do maybe pull speed 300. So pull speed is the strength at which it's attracted to the spline. As you can see, the liquid is being emitted and attracted to the path and is going to keep following the path until it reaches the end. And we're going to go over these path follow settings in the project that we'll do in this course later on. Now let's do body force real quick just for fun. So let me make a body force helper. Let's delete path follow. Let's delete the spline, and then maybe let's create just a extended primitive torus knot. Torus knot is a fun object as such, and we can go under body force and select this torus knot as our body force object. So now basically the liquid will be attracted to this torus knot, and it will keep spreading evenly until it basically morphs the object out of the liquid. So the important thing here is to right click, go to Phoenix FD properties, and make the torus knot not a solid object. So this way the liquid will not bounce off of it. It will just be able to go inside and just create the shape out of water. So let me show you how that works. So it's not really working well right now because the liquid is fighting gravity. So this would be one of the instances where you want to go under dynamics and just turn off gravity to make it easier. Otherwise you'd have to come into the body force settings and raise them up pretty high. The liquid is taking shape of the object, but it's still pretty fast, so it reaches the bottom here before it sort of comes back. So what we can do is increase the strength to maybe 300 and increase the press orbit just to sort of stop it from overshooting. So you can see right away it's being much better at immediately taking the shape of the torus knot, and we can extend our timeline to maybe 300. Now I can select the torus knot, go to object properties, and make it display as box. So now all I see is just the liquid. So now you can see as it's simulating, it's taking on the shape of the torus knot until it happens. And but this is just a quick example, and then what you could do is go maybe back under standard primitives and create a tube. So let's just make a tube like this, and you can bring the tube here, and you can go back under body force and just select the tube now, and basically all of the liquid will fly from the torus knot and it will try to now morph into this tube. So this is a super fun way to morph objects out of liquids or transition from one object into another, make a logo. All of the fun popular effects that you see online, you can pretty much do here. And the remaining helper that I want to touch on here is the PHX Turbulence. So this will just basically add some more variation to the movement of the liquid. So let me remove this force, let me remove torus knot and the tube, and let's go under the dynamic settings. Let's turn gravity back on. And let's do initial fill up, maybe 20, just so you can see how the turbulence works. And maybe we can do strength 200 for size. Let's maybe do 50. And let's run the simulation and see what we get. Now let's delete this liquid source because we don't really need this cylinder anymore. And let's make sure that our walls are jammed so that the liquid doesn't die. So let's go under grid and do jammed both on all axes, and then maybe we can raise the turbulence size to 100 centimeters and the strength to 300 and run the sim. Now you can beautifully see how this exact visualized pattern that it's showing you in this image is exactly what's happening to the liquid in here. So this is a great way to see what it will do and what it will look like. So basically the surface of the liquid is being displaced turbulence, and the turbulence is a great way to add detail to all sorts of simulations. It's a very useful helper to use, and I usually don't really mess with any of these other settings. The only thing that really matters is the strength and the size. You can maybe increase the rate of change if you want something faster, but that's about all I would touch. So just to recap, we just went over some of the various helpers that you can use. We are already familiar with the liquid source. Then we did the plane force to push the liquid in a certain direction. We did the follow path to make the liquid follow a path that we predetermined with a spline. We did a body force to make the liquid take shape of an object. And now finally we're using this turbulence to displace a water surface or a liquid simulation with some added forces. So I hope that you guys found this helpful, and I'll catch you in the next lesson.